Solve each equation by completing the square, then graph the related function. Well, let's do the first part. Let's solve the equation by completing the square. By solving this equation, what we're really doing is we're finding the roots. Roots mean x-intercepts, which are zeros of the function. So I take my first term, and I take my second term, and I group them together in a set of parentheses, leaving some kind of a blank here to the right of the minus 3x. I have my minus 88, and then I leave a blank to the left or right of that, doesn't matter, equals 0. To complete the square, you first want to make sure that the leading coefficient is a 1, which in this case it is. You then take the coefficient of x, which we usually call b, it's negative 3 in this case, you take half of it and then square it. Half of 3 is 3 over 2. And then you square it. So you take half of negative 3, which is negative 3 over 2, and then square it. If we add this to the problem, we have to also subtract it from the problem. The reason we do that is so we don't change the value of this equation, we just change the way that it looks. We add 1, we subtract 1. We add 7, we subtract 7. We add something weird, we subtract something weird. Keeps the equation balanced. By completing the square, that makes this trinomial a perfect square trinomial. So to factor that, you take the square root of the first term, which is going to be x, square root of the last term, the square root of something squared, the square root and squared cancel, so we get negative 3 over 2. Well, pardon me. If you square this, you're going to get positive 3 over 2. Scratch that again. If you square this, you're going to get 9 over 4, and then square root it, you get 3 over 2. So the sign there is always going to be positive when you square it. And then to figure out what the middle term, to figure out what the sign is between this, you look at the middle term. It's a minus, so we put subtract. Over yonder, to square a negative 3, you get 9. To square 2, you get 4. In order to put these together, I need to get common denominators. So I bring the x minus 3 halves squared down. This minus 88 I could make minus 352 over 4. So I get common denominators with the 9/4. If I put those fractions together, when you subtract two fractions, you subtract the tops, leave the bottoms the same. So once we get to this point, where the square has been completed, and you've simplified so that you've combined like terms, draw an arrow off to the side. We're going to come back to this part later. I'm going to put that on the next page, because this is the part that you're going to use to graph the related function. So we continue for this. We're trying to get x by itself to find the roots. So to get rid of the subtract monster here, 361 over 4, we're going to add 361 over 4 to both sides. And then to try to get x by itself further, we want to get rid of the squared, so we square root both sides. If we do that, we're going to get x minus 3 halves equals the square root of 361. Let me see what that is with the calculator. It's 19, and the square root of 4 is 2. If you simplify that more, 19 divided by 2, you're going to get 9.5. Well, let's just leave it as 19 over 2. And when you do square roots, you do plus or minus. So it's plus or minus 19 over 2 to get x by itself. Add 3 halves to both sides. So we get x equals 3 halves plus 19 over 2 and x equals 3 halves minus 19 over 2. So 3 plus 19 is 22 over 2. 3 minus 19 is a negative 16 over 2, and this reduces to 11 and negative 8. The x-intercepts, the roots of this equation, which is the first part of the directions. Solve each equation by completing the square. That means find the roots. You get 11 and negative 8. Second part of the directions, graph the related function. The related function, you take that part that we had the arrow beside, which was what I have written down here, equal to 0, but the related function, this is equal to y. This is the related function. The reason we want to use this version of the problem to graph, because looking at our parent graph, which is y equals x squared, this minus 3 halves translates the graph to the right 3 halves, and this minus 361 over 4 translates the graph down that many units. So step 2 is to find the related graph. Step 3, find the y-intercept. To do so, take the original equation but replacing 0 with y. And to find y-intercepts, you put zeros in for your x's. So you'll find here that the y-intercept is negative 88. If you put all this together, to graph this, our vertex is at 3 halves, negative 361 over 4. We have a y-intercept at negative 88. We have x-intercepts at negative 8 and 11. So we put all that on here. And we have our graph. And that's finished. Solve the equation by completing the square, then graph the related function. Solving the equation by completing the square, it means that we're going to find the roots of this problem. To do so, to complete the square, your lead coefficient is not supposed to be a 2, it's supposed to be a 1. We can fix that. So just like we started the other problems, we take the first two terms, we group them together, put a space after the second term because we have to complete the square there, and then put our constant out by itself, leave another space, and then put it equal to 0. Once again, to complete the square, the lead coefficient is supposed to be a 1. This isn't a 1, it's a 2. So to fix that, we are going to factor a 2 out of what you see in the parentheses. Not out of the 21, but out of these two terms. If you factor that to the front, we end up with x squared plus 11 over 2. That's what 11 divided by 2 is. Like so. Everything else stays the same. To complete the square once again, we take half of b. Half of 11 over 2 is 11 over 4. And then you square it. If we do it to the inside, we also do it to the outside. But we do the opposite. We can't just add 11 fourths squared to the problem. We have to also subtract it. Important to note, this, although this says 11 fourths squared, it's not. See this 2 out in front? This 2 is being distributed to each term. So whatever this thing is that we added to this, we have to double it because of this 2 here. Which means to counteract this, we have to subtract, I didn't leave myself enough space, subtract a 2 times 11 fourths squared here on the outside. That's supposed to go in this spot here, but I ran out of space. This 2, once again, comes from this 2. We're subtracting because here we were adding. adding and subtracting the same number cancels each other out. So we get this. Continuing, the whole reason of completing the square is so you get a perfect square trinomial. Here's where I got these numbers. This first term, x, is the square root of this first term, x squared. The second term, 11 over 4, is the square root of 11 over 4 squared. And the sign of the middle number goes here. I'm going to simplify this here first. If I square this, I get 121 over 8. 11 squared is 121, and then 4 squared is 16. Let me do this off to the side right here. 11 over 4 squared is 121 over 16, but then I'm multiplying that by a 2, which means that becomes a 121 over 8. So here's a little side work for this. Since that denominator is an 8, I'm going to want to change this minus 21 that I have here to have a common denominator. So I multiply the top and bottom of 21 by 8. I get a 168 over 8. Now I can combine these because they have common denominators. This whole thing is equal to 0. So I get 2 times the sum of x and 11 4 squared. 168 negative and 121 negative together is minus 289 over 8. Once you've simplified it, I'm going to be doing this on the next page, so I have room for it. This part right here is what I'm going to use for my related function on the next page. Continuing to solve this, I'm going to add 289 over 8 to both sides of the equation. Trying to solve the equation for x. Then I want to get rid of this times 2 that's here in front, so I'm going to divide both sides by 2, or probably more appropriate to say I'm going to multiply both sides by 1/2, which means the same thing. My execution here on the right becomes a little bit easier. 289 over 8 times 1/2 would be 289 over 16. And then I'm going to square root both sides. Run out of space here, so I'm going to bring this up here. If I square root the left, I get x plus 11 fourths. If I square root the right, I get plus or minus. 289 square root is 17. 16 square root is 4. If I subtract 11 fourths from both sides, I get negative 11 fourths plus 17 over 4 and a minus 17 over 4, which is going to be negative 11 plus 17 is going to be 6 fourths. Negative 11 minus 17 will be negative 20. Negative 28 fourths, I believe. Yeah, negative 11 minus 17. And simplifying these, I get 3/2, and I get negative 7. So after all that work, I found that my roots, my x-intercepts, were 3/2 and negative 7. That's step 1. Step 2, we're supposed to graph the related function. To do that, we first want to find the related function. To do that, I'm going to take this part right here, it's simplified on the left, and I'm going to replace the 0 with a y. So I replaced the 0 with a y in that equation, and I got this related function. Part 3 is to find the y-intercept. To find the y-intercept, I take my original version of this equation and replacing 0 with y, which is like this. And replace the x values with 0 to find the y-intercept. And you end up with a y-intercept of negative 21. So graphing this now should be pretty simple. From this here, we get a vertex of negative 11 fourths negative 289 negative 289 divided by 8. We have the y-intercept of negative 21. We have the roots of negative 7 and 3/2. So your graph looks a little something like this. No, it does not. It looks a little something like this. Y-intercept of negative 21. X-intercepts once again of 3/2 and negative 7, if I remember correctly. There's your graph. Solve each equation by completing the square, then graph the related function. So completing the square and solving it in this context means to find the roots, the x-intercepts. So you don't have to do this, but to be consistent, I'm going to set this problem up like the other ones were, which had all the terms on the same side. You could leave the 24 on the right side, and that would be completely acceptable. To complete the square, the coefficient has to be 1, which it is. You take half of b, so that's half of negative 2, which is negative 1, and you square it. Negative 1 squared is a positive 1. If you add 1 to the problem, you have to counteract it by subtracting 1 to the same side of the equation. Or you could add 1 to the other side. That would also be appropriate. By doing this, we have a perfect square trinomial, which factors like so. To tell how it factors, take the square root of the first term, you put it in the first position. Take the square root of the constant, or the third term, and you put it here. The sign of the middle term goes between, and it's always squared. A negative 24 and a negative 1 is a negative 25. Once again, once you have it simplified before you start solving it, that's what we're going to be using for our related function. To solve this, we add 25 to both sides. Square root both sides. Anytime you take an even root, it's plus or minus. So you end up with 1 plus or minus 5, which is a negative 4 or a positive 6. Those are the roots of this equation. Second thing we need to do is identify the related function. The related function replaces 0 with a y or an f of x, either one. We get y equals the difference of x and 1 squared minus 25, which makes the vertex for this graph, hopefully you can tell, 1, negative 25. We know it's a minimum because the lead coefficient is positive. Find the y-intercept of this. Take this original function, getting the 24 on the left, so we got y equals x squared minus 2x minus 24. This is to find the y-intercept. Put zeros in for your x's, and you have a y-intercept of negative 24. So to graph this, we have our x-intercepts, we have our y-intercept, we have our minimum. So graphing it, it's going to look like so. Our minimum is at 1, negative 25. Our x-intercepts are at 6 and negative 4. Our y-intercept is at 0, negative 24. Finished.